Welcome to
Good
the
afternoon, Rahul.
Yes, sir. Good afternoon,
Good
sir.
afternoon, sir. Good afternoon, sir.
So, welcome to the afternoon session of Day 3 AICTE-ISTE sponsored 1-week refresher program on recent trends in intelligent systems. Now, I request Dr. Rahul Jashvantbhai Pandya sir to please continue the session.
Thank you very much, madam. Am I audible, madam?
Yes, sir.
I'm sharing my screen. Let me know once it is visible.
Yes, yes.
Okay, Windows. Let me know when it is visible, madam.
Yes, sir. Yes, sir. It's visible now, sir.
Okay.
Yes.
Thank you very much, madam. So let me get started. In the first session, we discussed about the basics of 6th generation of wireless communications. In the second session, we took a look at the exercises of machine learning and some of the have seen two exercises. So in this third session, what we are going to see that machine learning is not still sufficient, and what could be the complements coming from the blockchain technology. So integrated role of machine learning and blockchain communication can play. Is my voice audible, madam? There was some network issue.
Yes, sir. It's perfectly audible, sir.
Okay. So the integrated approach of machine learning and blockchain in wireless communication plays an important role here. So first, what we are going to take a look at, since we have covered machine learning, we will quickly move on to that, and then we will cover basics of blockchain. And then we will see how the machine learning shortcomings can be complemented using blockchain, and blockchain's limitations can be complemented by machine learning in wireless communications. So this is kind of an idea proposition, which can be taken forward. Okay, so what we are going to take a look at the integrated approach. The outline of this one is the integrated approach of machine learning and blockchain together in the communication systems, and the transferred learning, right? So how is it useful, and how blockchain can complement that transferred learning, and what are the shortcomings of machine learning or transferred learning can be overcome using the blockchain. That we will take a look, and we will cover a bit detailed more on the blockchain's basics, because this idea is something coming out new. So most of the workshops are mainly focused on machine learning and AI, but very little on the blockchain. So we thought of giving an idea on the blockchain also, and we will discuss about the limitations of the blockchain and what are the benefits for each other, correct? And then finally we will take a look what are the open issues, challenges, and broader research perspectives for both the topics. Okay, so to get the integrated approach of blockchain and machine learning for communication networks, we have to study the main part of the blockchain and machine learning, and we have to look at the overview of the machine learning and blockchain and how they can benefit with each other. Okay, so we will be focusing more on the integrated approach. So not a standalone machine learning, not a standalone blockchain, but the integrated approach of both. So as we have seen, That 6 days primary requirements are to achieve the high data rates, ultra high data rates, improve the spectrum and energy efficiency, enhance the quality of services, throughput, and ultra low latency. All these are the wide requirements of sixth generation. Correct. So the necessity of the large data volumes, the massive connectivity that imposes some of the challenges on the research, resource management, and security and privacies. So these are the main challenges, right? So, and along with this, we want to make it intelligent, automated, and decentralized architecture, along with the security. Correct. So this could be achieved through machine learning. But when we go for the decentralized approach in transferred learning, what happens that we share too many data with other nodes. Correct. So that data sharing model sometimes it becomes unsecured, and that sharing mechanism is also not efficient. So in those cases, this blockchain, the application of blockchain is very important because its blockchain is highly immutable and decentralized. So that will help us to secure the entire machine learning architecture. And there are shortcomings of blockchain also can be complemented using machine learning. So that will improve. The blockchain can also significantly improve the training phase of my machine learning and deep learning, because in this decentralized manner, because the sharing mechanism becomes more efficient. So training phase becomes very efficient. We have covered this slide already, so I'm going to skip it. These are different types of machine learnings. So that we will skip. Okay, so the basic workflow of machine learning was we have to acquire the data sources, the training data sets, then we do the training, then the feature engineering, other things, and then once it is trained and ready, then it can be applied to the real set, and then we do the testing part. Okay, and then it can be deployed in the real application. So this was the general flow of the machine learning, right? And in sixth generation, what we have seen in sixth generation, what we have in sixth generation, what we have seen is the transferred learning. Correct? So in transferred learning, what happens? We used to transfer. Okay, so we used to transfer the models. So let's say this is the edge, which is dedicated to a particular segment. So across all the models are trained separately in the smaller segments, and they are transferred across those edges. Correct. Similarly, all the segments are trained separately. All the segments are trained separately, and transferred learning was happened. We have discussed more in detail in the previous lecture. So the requirements of this sixth generation, correct, and the complex segments will trigger the requirement of the need of the transfer learnings applications. And how we are going to look at this one. So the problems with the transfer learning or machine learning is so the first and foremost is the security part, because when we share too much, right, so all the data models are shared, it can be it can be a security breach. So security and privacy preservation is the most important aspect of the decentralized structure of sixth generation with transfer learning. So it could be easily hacked. It is very prone to the hacking and other things, right? So it could be, I mean, when you share data, the privacy preservation won't be maintained nicely. So that's the major problem. The second problem is, if you look at the machine learning centralized structure, the requirement of high amount of training data, correct? Requirement of large amount of training data, that is another one which will lead to the computational complexity if we go with a centralized approach. So that's the another bottleneck. If you go with a centralized approach, we have to, all the learning patterns have to be stored in the centralized server and access from there. So that's another bottleneck. Accessing and aggregating a large number of training data, that's another challenging problem in machine learning. Correct. So what if the center fails, right? So then there is no way to recover. Even if there is a backup one, then again we have to look at the fault tolerance mechanism, and those are troublesome issues in sixth generation when we have a centralized machine learning deployed there. Correct. So, and again there is an inefficient management of the data sharing. So all these are again, that's the biggest trouble, because we have to share everything, and if the efficient structure is not there, then that sharing becomes inefficient and occupies too much of resources. So these are the troubles of machine learning. So you can see, it's again, there are failure problems and too many other things. So now we can see the blockchain, how blockchain technology complement all this, complement machine learning, and it can eliminate or help us to overcome all these problems of my machine learning issues. Okay, so let's see the blockchain. So we will go through the introduction to the blockchain. We will touch upon a bit on the blockchain terminologies, how the cryptographic components help us to preserve the privacy of each model when it is each node when it is sharing a data model. Correct. What are the consensus components to build a common trust agreements? Different structure of blockchains and types of blockchain we will take a look, and we will look at the smart contract theory also. Okay. So blockchain. So what is blockchain? We have covered machine learning in first two lectures. So assuming those two lectures are in place, I'm starting with the blockchain. So what is blockchain? Before I go further, madam, is voice clear? Screen visible?
Yes, sir. Yes.
Okay.
Yes.
So basics of blockchain. So what is blockchain? The blockchain is a distributed ledger that involves a set of immutable transactions among the untrusted parties without any centralized controller or human intervention. So let's say there are multiple nodes in the network, right? And they want to share something, or they want to make a transaction across them. So let's say, for an example, if I have to transfer an amount to another party, so I have to transfer it through bank, right? So all the transfers are through bank. So bank is the central controller here. Everything has to go through the bank. Now the blockchain is a decentralized structure. It says that it's a decentralized ledger. Whatever the transactions are made directly between those two parties, and bank is not coming in between. So the control is not there in the bank. It's completely decentralized. That's the idea behind this. So transactions on the blockchain are grouped and stored in a persistent manner, and they are immutable. Once the transaction is stored in the blockchain, it cannot be changed or it cannot be altered. Second thing, it is distributed. It is transparent to all the nodes. All the nodes, they have the copy of all the all the transactions in a blockchain. So if any hacking or any tampering happening, that would be automatically detected here, because the copy is distributed across all the nodes. It can be verified through the consensus mechanism. We will go through in detail about that. So it can be verified through the consensus mechanism before adding a new block to the chain. It's a completely decentralized governance. So that's very good, right? So, and the major advantage of the blockchain is like decentralization, transparency, immutability, security, and the identities are not disclosed. It's completely all the identities are are encoded through the cryptography. So none of the identities will be disclosed across the block, across all the nodes. So everyone's privacy is preserved. So the basic example of a blockchain is this one. So let's say there are 4 clients and 1 bank, right? So bank holds the golden record. It has everything. We have to do everything through the bank only. So if I have to transfer an amount to someone, I have to go through the bank itself. So everything goes through the bank only. So if, let's say, if there are any discrepancies in the transactions, right? So in that, what happens that the bank's record is always correct. And if there are discrepancies, we have to go to the bank and convince the bank that this transaction is not correct and there is a discrepancy, right? So that's a headache. So this is our centralized ledger, correct? Whereas cutting down the middleman, so directly, so the blockchain concept is a decentralized ledger. It establishes the interface between all the nodes, cutting down the middleman, enabling us a direct transaction between two entities in such so that there is no bank or no central version, right? So no central controller. So there is only a single ledger which is shared across all the nodes through the blockchain, correct? And there is a consensus protocol, which is a common protocol which is agreed by all the parties, those who are doing the transactions, so that okay, this is a common protocol based on all the blocks of transactions will be added and shared across all of those. So let's say if I transfer amount from node E to node A, that new block would be added in the blockchain, and then that would be stored across all the nodes. So they will be transferring that copy would be transferred across all of those. So they know that. So anyone can add a block of transaction there based on the consensus protocol, right? So you can see it's completely a distributed ledger rather than the centralized ledger. So here we are eliminating a complete we are eliminating the middleman completely here. So the basic blockchain's workflow is presented here. So let's say if any transaction happens between any two users across this network, any transaction. So in wireless communication, how it is useful. So let's say node 1 and node 2 are transmitting data with each other, correct? So let's say some of the frequencies we are occupying, we will try to link with wireless communication in a while as soon as I explain this. So some of the frequencies are getting occupied at data at some of the data rates, correct? So all these frequencies, they will be blocked and stored across the blockchain and shared across all the nodes. So they will be coming to know that this frequency is occupied for this much of
సార్
time.
హిమజ చెప్పండి సార్ చేస్తాను. పంపించారు నాకు ఏమేమి డేటా ఏదేది చేయాలో చెప్పలా, అవన్నీ అయిపోయినాయి.
Okay, thank you very much, madam. So when a transaction is executed between any two users, it will be hashed and broadcasted to each node of the blockchain, right? So let's say these two are transacting with each other, okay? So the new block is created with the transaction data, correct? With the transaction data, and this block is added into the chain. So let's say this is my first block, then second block, then third block, and then so on. So new block would be inserted into the chain at the end of the chain, following the consensus protocol, right? And then it would be given to all the nodes. The copy of this block.
To interrupt, sir.
Yeah.
Sir, are you showing any slides? All we can see is only one slide with the name blockchain technology.
Oh, is it?
Yes, sir.
Oh my God. That's a problem. That's good, madam. You could have slid slightly early. Please let me know now.
No, sir. We couldn't see any slide. Yes, sir.
Is it changing now?
Yes, sir. Yeah. Yes, sir.
Do you want me to repeat, madam, from the blockchain technology? A quick recap?
Yes,
I'll
sir.
do a quick recap.
Bank, yes, sir. From that bank example, we couldn't see any slides, sir. So I thought you were giving example. Yes.
From here? From here, madam?
Yes, sir. Yes, sir. From here we couldn't see. Yes.
Okay, madam. Thank you very much for informing, because this happens in this online mode sometimes.
Yes.
Okay.
Yes.
So in blockchain, what happens that, let's say in the bank's example, a quick recap, if I transfer an amount from B to A, correct, I have to go through the bank only, and bank holds the golden record. So it has so if I see any transaction discrepancy, I have to go to bank and convince him, either through the online mode, writing the email or raise a customer service request, correct, or call them and convince them that there is a discrepancy, please check, correct. So bank holds everything at the central level. Now in blockchain, what happens that the transactions are happening in the decentralized manner, cutting down the middleman. So now let's say if anyone transacting between these two nodes, right? If the E transacts with A, the transaction happens and that record will be stored in the blockchain and shared across all the nodes. So all the nodes will have a copy of a blockchain, correct? And they will come to know that there is a transaction between these two, right? Now the privacy comes, it's highly encoded through the cryptographic algorithm, so no one will know who are these two. Okay, they assume that okay, they come to know that there is a transaction, but who are these two, they will not be come to know. So that would be protected. So, and these transactions, are based on the common consensus protocol. So for an example, they have one agreed protocol, and as soon as this protocol is satisfied, the transaction will be allowed automatically. Correct. So that's the basic principle of the blockchain. So now, is this visible, madam? New slide, madam.
Yes, sir. The old slide on. Yes, sir. Now visible, sir. New slide. Workflow
There
of
are
blockchain.
two user one, yeah, workflow of blockchain. Okay. So there are two users. Correct. If the let's say these are multiple blocks in a network. If I say with respect to communication network, now let's say node 1 wants to transmit to node 2. So it is going to block some frequencies at a particular data rate it wants to transmit. Correct. So that transaction data would be stored and inserted in the blockchain. Once it is inserted in the blockchain, that blockchain would be shared across all the nodes, so that they will come to know that this frequency is used by a particular user and we will not use that frequency. So that data sharing would be done through the blockchain. So you can see when we execute the transaction between these these two users, it would be hashed and broadcasted to each node in the blockchain. And those transactions are happening based on certain consensus protocol. So based on this consensus protocols, transactions will be happened as soon as they are satisfied. And once it is done, it would be stored. New block would be inserted in the blockchain and then transmitted across all the users. So basic illustration of a block. So if you look at this, the block, how is it configured? So each block includes a number of transactions which is linked to the previous block. So let's say there is a new transaction here. So this is my new block with new data. Now, how is it linked to the blockchain? That it has a pointer to the previous hash of the block. The previous block's hash is pointed here. Correct? This is my previous hash. So now this is my existing block. It has the previous block's hash again. So same way, the entire chain is created by linking those hashes, and the new block hash would be stored here. Correct? This is hash. We will see what is the meaning of hash here. We will see very soon. So generally the block includes two parts. So the header and the data. So this is my main data, and this is a block header. Like block header, it includes such as a block hash, which is kind of a cryptographic encoded key, or maybe cryptographic number, which is encoded here. We will see how it is happening. It includes the previous block. It includes the number used once. Nonce means number used once, which is linked with this hash when it does the cryptographic part, and then timestamp when the block is inserted in the chain. So now this is how the chain is created of a block. Correct? So the general blockchain approach, if you look at this is my blockchain ledger, shared ledger. These are different parties participating in it. So the shared ledger will hold all the transactions, and it would be shared across all of those. There is no bank or no central controller here. Correct? So all the records of the transactions are stored and in the blockchain, and it would be shared across all the nodes. That's a basic assumption, right? So the advantage of is, now if someone tries to hack it or someone tries to alter some of the transactions, what happens that everyone holds a copy. If there is any discrepancy at any level, we can immediately identify that the party is trying to temper the blockchain, and then security breach is detected. So immediately we can detect it. And once the transaction is stored in the block chain, once the block is stored in the blockchain, it is irreversible. It cannot be changed. That's a basic idea. It cannot be changed. It cannot be changed. So now this is open to all. If there are multiple types of blockchains, now there is a discussion. Why should it be seen to everyone? It cannot be, it should be privatized. So if it is a public blockchain, anyone can see it. But if it is not a public blockchain, if it is a private blockchain, everyone cannot see it. You need a permission from the authority. So in that case, it is called a permission blockchain. We will see. Correct? So only the permitted people can see the transactions and other things. Okay. So the next is the consensus protocol. So it's kind of a trust building part. Right? So before adding any new block in the chain, there must be an agreement. So across the participating nodes. there must be an agreement across the participating node that based on this basic agreements, we are going to allow the new blocks in the chain. So that protocol is known as the consensus protocol, correct? So before we add a new block in the chain, there must be an agreement across all the participating nodes that okay, this is the protocol. If that is satisfied, we will allow the new block to be added in the chain, correct? So that's called the consensus protocol, correct? So there are several consensus protocol like proof of work or proof of stake or proof of activity or practical Byzantine fault tolerant mechanism, and there are too many others, correct? So we will take a look at two of those, that what are the consensus protocol and how they work, right? So first, is this visible, madam? Proof of work slide.
Sir, no, sir. Can you please share again your screen?
Okay, it's not visible, madam.
Yes, sir. Not visible now, sir.
Oh my God. Okay.
No, sir. It is visible till now, sir. Now it's not visible, sir. Please share once again.
Okay. I'm sharing my entire screen. Is it visible, madam? Proof of work.
No, no, sir.
Let me disconnect and join back in a minute. I'll try to refresh my connection. Just 1 minute.
Yes, sir. Okay, sir. Do the participants or attendees, do you have the same problem? You couldn't see the slide, or there any network issue with only me? Please respond.
Same thing, problem coming.
Okay, sir.
Is it visible now, madam? Please let me know.
Yeah, sir, it's visible.
Proof of work, right? Is
Yeah,
it changing? I'm changing some of the slides. Can you check? Is it changing?
Yeah,
so
yeah.
that
They are
my
changing. Yes, sir, they are changing.
okay. Because I want to make sure that we deliver as per the expectation, because otherwise I would be keep speaking and slides won't change. So doesn't make sense.
Yeah, sir. Yeah.
So proof of work. So the proof of work is a protocol. So proof of work is that, I mean, so general idea, if I give, let's say, if I want to get a job somewhere, correct? So I have to demonstrate my proof of work that, okay, I hold this much qualification. I work, let's say 5 years, 10 years, 20 years somewhere. I have this much of experience. Please give me this job, correct? Please appoint me on that position. I have to clear the interview and show the proof that I have enough qualification, professional qualification and educational qualification. After I give the proof of work, the new organization will allow me to enter and give me the job, correct? That's a simple protocol. If I do not hold any qualification, nothing, and if I just go and say, give me a job, I mean, nothing is going to come, right? I won't get an interview call also. So that's a proof of work. So proof of work is used to confirm the transactions and produce a new block. So for an example, let's say there are new blocks have to be added in the blockchain, correct? So these miners, so these are called miners. So if I zoom it for you, so these are called miners. Each each node in a blockchain can act as a miner. These miners, they do the mining and add a new block. in the blockchain. So let's say if any transaction happens, for that particular transaction, there would be a hash puzzle, mathematical puzzle would be required to solve, and then once the puzzle is solved, new block would be added. So as soon as, see, all the blocks can, any node can act as a miner as soon as they have the computational capability. So as soon as the block has to be created, the pending puzzles would be solved, shared across the nodes, and let's say this people are ready to solve them, and then there would be a competition. So here there would be a start point. From that they will start solving that mathematical puzzle or hashed puzzle, right? And whoever is successful, he will be a winning miner and he will add that block in the chain. So let's say across this 6, this is successful in solving the puzzle, mathematical puzzle which has been given, and then it will add the transaction in the block and new block would be compiled in the blockchain. Correct? Now this is good, but what happens? So let's say 2 of those are successful in the at the same time. Now there is a competition. What happens? That could be a fork creation. That could be another blockchain wing would be created if there are 2 of those are successful at the same time. If only one is successful, it's going to add a block in a chain, no problem. But if there are 2, then what happens? There is a fork creation. So let's say till this, a new block is added by 2 miners. This is 1, this is 2nd, correct? So again, 2 wings of blocks are created. Now that's a trouble. This is called a fork creation, correct? That's a trouble. So only one chain has to be a winning chain. So then we have to identify that who is going to be the winner across these 2 blockchains. So there are 2 forks. We cannot, fork is created, we cannot allow them to proceed further, right? That's a trouble. So now see, the process of solving those puzzles or cryptographic problems or complex mathematical problems is called mining. Process of solving those puzzles, cryptographic puzzles or mathematical problems is called mining. So let's say any resource is requested, correct? Any transaction is requested, those miners will start solving a computational problem. So let's say these are the blocks already added in the chain 20, 21, 22. And let's say some of the transactions are happening and these are the pending facts they have to solve. As soon as they start solving, so let's say there are 3 miners, miner number 1, miner number 2, miner number 3, correct? They will start solving the pending facts, and whoever is successful across these 3, at the end, he should be allowed to enter a new block in the chain. Right? So see, block number 23 is under solving. Block number 22 is already in the chain. At the end, block number 23, the puzzle has been solved by this 3rd miner, and this 23rd block is added in the chain, and that chain is shared across all the nodes. So all the nodes will come to know that that 3rd miner has been successful and he has added a new block. Right? So that's how it works. So now in wireless communication, what happens whenever we request a particular resource, the transaction would be stored in the blocks and shared across all the nodes. So they will come to know that this is a blocked resource. On the contrary, when the resource is released, when someone stops using that, the new block is created for releasing the resources, and that would be shared across all the nodes through the blockchain. So that people will come to know, all the nodes will come to know that that block is not used, and that frequency or any resource is not used, and we can start using that. That's called mining. The fork, I have explained you that when multiple miners, they get success together, so then there is a collision, correct? And then the 2 wings would be created of the block. 2 chains would be created, and then we have to solve that problem and say only one has to be successful across these 2. Now there is a consensus protocol. So the proof of work. So there is one more consensus protocol called proof of stake. Now in the problem in proof of work, what happens is, let's say proof of work, that means they are allowed to do the mining if they are able to show that they are capable. So first they have to solve the mathematical problem, just like an interview, right? I have to crack the interview to get a job, correct? I have to crack the interview to get a job, correct? So the probability of mining a block, it depends on how much work is done by the miner in previous domain. So he has to solve the problem. If he's successful, then he is getting a job. So if he is successful in solving the mathematical problem, his block would be added in the chain. Whereas in proof of stake, that means it says, where are you working right now? And based on that, we give you a job straight, right? We won't do the quality check, or qualification check or other things. So, we don't do the interviews again. So based on where you are working right now, based on that. So for an example, let's say the GATE exam, correct? So if the GATE exam is cleared, right? Some of the PSUs, they give the jobs to the GATE holders without taking any interview or anything further. Like some of the, PSUs, they give it directly based on the GATE. Correct. So it's called a proof of stake. If you hold the GATE qualification, directly we'll give you a job. So in the proof of stake protocol, what happens that you can mine it. If you hold the credentials, you can mine it straight. We don't want to do the checking again. We assume that you are qualified, and then we'll give you a mining position straight. You can go ahead and mine. So this is the difference between. Now the problem in proof of work is, let's say there are multiple miners, right? And then let's say there is a 51% attack. So let's say majority of those 51%, they are malicious miners, and then they can hack the blockchain, and then everything can go off. So security issue is there in the proof of work. Whereas in proof of stake, what happens that the POS systems makes any 51 attack more expensive, because they look for. So let's say if I have to hire a JRF position, correct, through the project fund. So what I say is I have to look at the at least minimum GATE qualification. So it should be a GATE qualified person, correct? So it gives a sanity check that, okay, he has cleared the GATE, so at least some sort of qualification is there with him. So it gives, those who are not holding the GATE score, valid GATE scorecard, they won't be allowed. So it becomes more expensive here. It becomes, right. So the miners we check that how much credentials is he holding in the previous domain. Based on that, we allow them to mine. So it becomes more attack prone. So security is important here. So this is how the proof of work and proof of stake works, right? Well, both of the work. Now, the next is to look at the types of the blockchain, the types of the blockchains, right? So different types, such as, let's say, public blockchain, private blockchain, and consortium blockchain or federated blockchain. There are three major types: public blockchain, private blockchain, and consortium or federated blockchain. In public blockchain, anyone can take a look at a blockchain without any permission. All the nodes are allowed to see. All the nodes are allowed to see what is happening, right? The ledger is shared and transparent to everyone. But now there are problems. It becomes slow here. You will see that. And in private blockchain, now the question comes, if everyone is able to see everything, it's not secured. Correct. Then it's a private blockchain, or you can call it permission blockchain. So now only the authorized nodes, they are able to check all the transactions. Now the question comes, it's too much privatized, correct? Again, anyone can alter it without the knowledge of any others. So the security is a trouble here also, correct? So then there is a third one, which is called federated blockchain, which is consortium blockchain also, which is the hybrid version of public blockchain and private blockchain. We will see in a while. So in public blockchain, there is no permission required. Anyone can join and participate. They can see the transaction. It's completely open and transparent. Anyone can send, receive, check the blocks, add the blocks, verify the transactions. Who are the participants? Anyone can see it, right? Anyone can do anything. So who are the participants? That cannot be seen because it's highly cryptographically encoded. But anyone can do the blocks addition. Anyone can verify it. Anyone can see the copy of a blockchain. And everything is transparent. Now that comes with a trouble because it's slow and it's computationally expensive. Correct. So this prevents the public blockchain from being now the advantage of this one is since it is transparent to everyone, this prevents the public blockchain from being hacked by anyone. So let's say if this user tries to alter some of the blocks and do the hacking, now anyone can see the ongoing blocks because they have a copy, so that immediately they can raise the alarm that there is a security breach. Someone is trying to change or alter some of the blocks. So that's how it is very secured. But the computation complexity is super high here. The second type is private blockchain. In private blockchain or permission blockchain, only the nodes that have the authority, they can participate. Now the problem here is, let's say those authorized node, they go and they decide to go malicious, so they can do the security breaching here, because those nodes can alter anything, or maybe they decide not to show because it's not transparent. So there is a problem here. So this is another big problem, but it is slightly fast because they are privatized and not shared with everything, not shared everything with everyone. So computationally it is slightly light and it is a bit fast performing. Now here the blocks are published by delegated node within the network. Some of the rules or even the data could be modified or tempered by the authorized node, that we have discussed already. So to hybridize the advantages of both the blockchains, third type is the federated blockchain or consortium blockchain, which operates by the group of pre-selected nodes, and the nodes do not have the authority to send. So all the nodes will not be able to send or check or verify in that block. Only the constrained people, but what happens that they can put a request to the authority and they can allow it. So it's somewhere in between the public blockchain and private blockchain, and try to take the advantages of both of those. It's not so heavily computationally expensive because it's somewhere in between, and then try to maintain the optimal balance between public and private blockchain. So that's the thing. Now what happens, how the transactions are happening across the blockchain. So there is a smart contract. Now smart contract, that means what? It's a simply program, correct, which is stored on a blockchain that runs when a predefined condition is matched. Correct. So let's say there is a subroutine like if, when, then, this, like that. So for an example, let's say I have to send a money or amount to someone. Correct. So for that I need some balance in my account. That's the first assumption. For that I need the balance in my account. So what bank is, when I transfer it, what online algorithm is going to check, is he having the positive balance? Yes. Is he having sufficient balance? Then he is transferring. Is he transferring? Yes. So all these checks, if then checks are verified. If they are verified, it will automatically execute the agreement or that transaction and then transfer the amount, right, without any intermediaries permission. Correct. So that is called a smart contract. And it executes the action as soon as the predefined conditions are matched. So for an example, this smart contract is happening, but there is a trust issue. Correct. Now the trust issue. So what happens? I'm ordering some items from the online portals, but I do not trust it. Let's say Flipkart or Amazon, those two I trust. Now let's say if there is ABC company, e-commerce company, which I do not trust. Now let's say, what if I order it, I pay the amount, but they do not send the item to me? What if it is dealing with the delivery partner? Now delivery partner has to get the commission from ABC, and if the commission is received, correct, and then delivery partner takes care of the delivery. So what if this XYZ, which is a delivery partner to ABC, gets fraud? Correct. Then these all are the troubles. So there is a trust issue. Now using the consensus protocol, trust has to be built upon, right? So let's say using the consensus protocol. So for an example protocol, let's say COD. So ABC says do not pay anything to us right now. Correct. We will give your item to XYZ. XYZ will deliver you. Correct. At that time you give the payment to the XYZ, cash on delivery, and they will pay us and keep their card. That's one model. Second model, you pay us, but we will not pay to the delivery partner unless they deliver you the item. As soon as they deliver the item, the payment would be released to XYZ. Correct? That cut would be released to XYZ. So these are the trust mechanisms. So these are called consensus protocol. Based on this, if they are satisfied, those then the trust would be built upon, and then the transaction would go and executed with the concept of smart contracts, right? So the benefit of the smart contract is speed and efficiency is very high, correct? Because once the condition is matched, it should not go to any intermediary. It should go ahead and directly execute the transaction. So speed and efficiency is very high. And the third one is accuracy should be very high, because definitely because it's automated, completely automated. And the trust and transparency is also high, because there is no third party involved and entire transaction is encrypted and recorded. So trust and transparency is also very high. Security is also very high, because it's difficult to hack and it's completely encoded using the cryptographic algorithms. And there is a saving, because we don't get any redundant just 1 minute, I'm taking some water, just 1 minute, few seconds. So savings are very high, because they remove the need of any intermediaries. So unnecessary time delays or unnecessary additional blockages because of the intermediaries are saved. Correct? Now, the major issue comes is the privacy issue. Correct? Major issue comes is the privacy issue. Let's say the participating nodes, they don't want to disclose their identity. Or when they are sharing the model, they should be highly encrypted. It should not be hacked over the blockchain. So that's why the transactions, they should be privatized, or they should be highly encrypted so that no one can see. Identity should not be disclosed so that no one can know these parties who are transacting with each other. And those transactions, they need to be authenticated. That's why the cryptography plays an important role here. So that's why we need those hash functions, digital signatures, and cryptography. So in cryptography, the encryption and decryption happens through the keys and through the hashing in such so that no one can decode it so easily. Correct? So there are two types of major cryptographies, like systematic cryptography, symmetric cryptography, where we use the same key across both the parties, and asymmetric cryptography, where we use different keys across both the parties. Correct? So we will see one by one. So in the cryptography, the hashing means what happens that when I say any message, when I share any message, it would be hashed through a particular coding algorithm and then converted into the number, which cannot be detected so easily. Correct? In symmetric cryptography, what happens that I'm going to use a symmetric key at the transmitter side and encrypt my message into the encrypted message. The hello is encrypted into the encrypted message. And at the receiver side, using the same key, symmetric key, the receiver will unlock that message and deliver it. In asymmetric encryption, what happens? I'm going to use one public key at a transmitter side, and it would be broadcasted across multiple of those. And each receiver can use its private key and open the message. So only those who are holding that private key, they can open it. So the hacking remains difficult here. So for an example, let's say simple hashing. If I want to convert this number into the hash, correct? If I want to convert this number into the hash, what I do the modulo 15. So if I do 2, 3, 4, 5, I take the modulo with 15, I get a number 5. So this is the hashed number. Correct. So for an example, let's say this is my key star in bracket -1. Using this, I encode this message, and whatever the resultant is there that I transmit, using the same key, it can unlock it. Correct. So similarly, this asymmetric one will apply another key. So this is my public key, but this is my private key. Using private key, anyone can lock it, but they have to have a pair of the keys, right? So this is the public key and private key has to be paired and communicated before. Correct. So now let's take a look how the hashing happens. Correct. How the hashing happens. So far, so clear, madam. I'm starting a demo. Are you able to see this?
Yes, sir. Yes, sir.
So this SHA, secured hashing algorithm, SHA, secured hashing algorithm, you can see SHA 256 is secured hashing algorithm. What is going to do? It's going to create a hash for any message. So now, if you want to understand, we can go to this particular site and understand how it is creating the hashes. Okay, so I'm sharing my entire screen. Able to see, right, madam? I am sharing my entire screen and going to that particular site.
Yes, sir.
Okay. So this site we can go. Now we have to link with wireless communication soon. Okay. So first the basics I'm giving here. So after that we can see. So now this you can see this is a blockchain demo portal for students so that they can understand what are each elements here. So first is hashing. So this is my data. Let's say hello. Okay, welcome to the program. So here you can see using SHA, secured hashing algorithm 256. Applying this is the standard algorithm. Okay. Applying this, whatever the hash is there, that is coming here. So see, I have generated a hash. Now, this is analogous to here, what we have discussed so far. So see, look at this. That is a hash in the block. This is my hash, block hash. You can see this is my block hash, which I have generated here. Correct. So this block hash, which I have generated here, this is, you can see very encrypted number, correct? This is going to be stored here. And only those who are holding that SHA 256 understanding, they will be able to decode and identify, right? So it's difficult to hack. So using this hashing, I have generated a hash. Okay, I have generated a hash. Yeah. Now, once I generate the hash, I have to generate a block, correct? And I have to mine it. So I will go on the same portal and then click on the block. See, this is the hash I have generated, correct? This is the hash I have generated. Now I will click on the block. So you can see block. So this is my block number 1. You can give different block numbers. None says number used 1. Some seeding number is generated here. Whatever the message you want to enter, you enter it. And corresponding hash is generated here in the block. Once this has happened, now I have to mine the block. Now I have to mine the block. As soon as I click on mining, what it is going to do, it is going to mine this, and the block is mined. That means the mathematical puzzle has been solved, and this block is ready to be inserted on the blockchain. This block is ready to be inserted on the blockchain, right? So far what we have done it till here. So let me copy the slide here so that you can understand it easily. Okay, so we are here. Yeah, that's the part. Okay, so here what we have created so far is, as soon as, see, first we have created a block hash and stored here. After that we have created a mining. After that I have entered the data and we have performed a mining. And as soon as it is mined, right, color has been changed to green and the block is ready. So now this one block is ready. This one block is ready. Now let's create a chain. Now let's create a chain. So you can click on a blockchain. Now let's create a chain, blockchain. So now you can see there are different blocks here. So you can see block number 1, 2, 3, 4, 5, so on, right? So you can insert more number of blocks. Now let's take one real-time example and understand how the blocks are created. Okay. So see, what I have to do is I have to create, let's say, take the example. This is my communication network. Node number 21. Node number 21 wants to communicate to node number 5. Node number 21 wants to communicate to node number 5 at a data rate of 1 Gbps and with a BER of 10 power minus 12. Okay, so that's a transaction on my wireless network. That's a transaction on my wireless network. So what am I going to do is, I'm going to create one resource block on a chain. So let's create one resource block on a chain, right? So I copy and paste this information in the blockchain. Block number 1. Now see, the color has been changed to pink. That means as soon as I enter this block number 1, see now here the previous block is 0000. So it says there is no previous block. This is called a previous block hash. See, this is the first block, correct? So there is nothing previously deployed on the chain. So that's first. So that's why this previous hash is 000. As soon as I enter a new resource request on a communication network, a new hash is created and it will be changed immediately. If you do a little change anywhere, it will be changed. You can see a live changes, right? So this is my requirement. And then, okay, so I have to initiate the communication between these two. So what I do is I go and do the mining. It would be very quick. As soon as block is mined here, it would be converted in a green. And this chain would be shared across all the nodes. So they will come to know that 21 and 21 to 5 connection is established and that those resources are blocked. So for an example, let's say I'm reserving my frequencies. So no one can use it because it's been blocked here, correct? That's my first. Now let's say we want to establish a new communication from node number 7 to node number 12. So let's say node number 7 wants to communicate with node number 12. Node number 7 wants to communicate with node number 12. So I have to book different resources what are booked here, correct? How will I know that I'm going to book the different resources? I have the access to that blockchain, correct? I have the access to that blockchain here. So I will come to know that, okay, these resources are blocked. You can enter the frequencies also. Let's say f equals to x to y frequencies, right? So those frequencies are blocked. So now you can go ahead and enter the new set of resources here for a reservation. Second block, let's enter frequencies also. Let's say I want to use frequency of let's say 1 terahertz, okay, or let's say 1.1 terahertz. 1.1 terahertz, okay. So I'm going to, and this you can see this block, let's say is using 1 terahertz, a frequency of 1 terahertz. Right. So then you do the mining. Okay, so now this is my second block I'm adding. So it's, you can see exactly the previous block hash 00004 C4C C4C is padded here in the second block. This is my previous block hash is linked here. Now this is my current hash generated based on this resource request. And as soon as this is there, I have to do the mining, correct? So then it will automatically be mined here. As soon as it is mined, the second block is added here, correct? And then second block is added, so that connection has been established between 7 to 5. The frequencies are blocked here. Similarly, see, this is pink, that means this is available, correct? Green, that means they are booked. Now let's say this one wants to release, correct? So it's, you can add a new block. Let's say block number 3. Block number 3, what it says that node 21 to node 25 release frequency are released. So this, it has terminated. F equals to, I can say release. F equals to release. You can give a release command here and then mine it. So after this mining, what happens that those communications are over between 21 to 5 and the block has been released. A new block is added for releasing the frequency. So now everyone will know that, okay, that frequency was used and released. Now I can reuse it again. So other node can reuse that 1.0 terahertz. Other node can reuse that 1.0 terahertz, right? So similarly, you can see how the resources are reserved and shared across the blockchain, right? So this is the structure what we have seen. This is the structure what we have seen, the block 0, block 1, and so on, right? So correct. So that's the blocks we have added here. We have seen on the sharing of the blockchain. Okay, so now the programming part, so the demo which I have given, it was just for understanding part, correct? So this similarly you can code it, the blockchain along with machine learning. So mostly people use the Python because we have a very good machine learning interfacing with Python. So we can use the Python, but other people can use C++, Java or some others also. But when you want to integrate with machine learning, it has to be on Python because machine learning works on Python. So it works very nicely on Python along with the machine learning, the integrated approach with blockchain and machine learning, correct? So there are nine fundamental modules, of the blockchain architecture, correct? First is the identity management. Those identities shouldn't be disclosed, and second is the program development. This blockchain program has to be developed and integrated. Then the information propagation. So what happens, that new block is added and the entire blockchain has to be shared across all the nodes. So that information propagation is also important. New block proposal. So let's say two nodes are reserving the resources. So they propose a new block and it should be mined, and if it is satisfying the consensus protocol based on the security, and then based on the smart contract, it would be approved and inserted in the blockchain, correct? And after the block is inserted in the blockchain, it should be verified. So generally the verification is not a difficult task. Mining is a difficult task because mining involves with high computational resources. So as soon as the new block is inserted, it would be transmitted across the network, and that would be verified very easily, correct? And after the verification is over, it would be confirmed and it would be stored across the blockchain and everyone will have a copy. So these are the nine fundamental principles of the blockchain architecture. Now, how is it useful? How is it useful, madam? Madam, is screen visible?
Yes, sir.
This top something is coming black bar. Is it hiding my title for everyone or not? This presenting and
No, sir.
okay, fine. So it's going well. Okay.
Yes.
So yeah. Okay. So this now the question comes: how the blockchain can be useful from the communication network, from the from the perspective of the communication networks. How can we integrate it? That's a major question, right? So we have seen the blockchain properties. It is highly secured, privatized. I mean, the privacy is preserved here, and it is highly secured and immutable. So security breaches cannot be so easily made. So these are the properties, and there are nine fundamental modules what we have discussed just now, and then how we apply them. So for an example, let's say we have a problem of spectrum sharing. Now, how we do the efficient spectrum sharing? These blocks, they can be created based on the requests and which can be driven through the machine learning. So there could be an integrated approach. We have seen how we have booked the resources for a block for between two nodes, right? Using blockchain. Now this can be driven through the machine learning automatically. The control of a blockchain can be there in the hands of machine learning. And since we are doing the distributed machine learning, it can be through the blockchain because it has a highly secured and distributed architecture. This can be applicable to the spectrum sharing also. Now, network slicing is another application. Network slicing means you have a bigger network architecture which can be shared across multiple vendors with custom modifications. Right? For an example, if you take a look, one tower, now there won't be any a single company who is holding their antennas there. So for an example, let's say if they rent a site, I mean they take a site on a rent and deploy the base station, I mean the towers there, right? So on that you might see, we may see Jio's antenna also, Airtel's antenna also, Idea Vodafone's antenna also. And then they do the coexistence, and then the rent would be splitted across these three. So what happens that all three, they share the infrastructure. That's called a slicing, right? So one site has been sliced across these three. So let's say if I have two kids, correct? And if I get a dairy milk, so I have to cut it down into two parts, correct? The only thing is, only constraint is I don't want to purchase two dairy milks. I want to purchase only one dairy milk. So that I have to split across those two. So that's called a slicing. So let's say if I have a network infrastructure developed and if I have to share it across multiple vendors, this slicing can help very nicely, and it could be dynamic across the blockchain. So different customers or vendors, they book the resources or network infrastructure in a custom manner across the blockchain, so that they can have the desired slice, right? Desired slice. And there are network coding and authentication is also another important part of a blockchain. Now, the major advantages of the blockchain is decentralization, transparency, immutability, security, and pseudonymity. Pseudonymity. So what happens that identity, we do not disclose it. Though there are limitations. I mean, now there are certain limitations which will block my advantages, and then the application of blockchain to the communication networks becomes limited. First one, when there are too many users, there will be too many blocks for resource blocking or any other performance request. So what happens that there will be an extensive mining and block addition mechanism would be involved, and that consumes a lot of energy. That's a major bottleneck of blockchain. And we need high computational machines for mining purpose, which consumes again a huge energy. So computational complexity becomes very high because they have to solve those mathematical puzzles, which consumes very high energy, and it requires very large amount of computational resources. So that's why these are the major bottlenecks. The second one is the scalability is the issue, right? When number of transactions are too many, the scalability is a trouble. How many blocks will you add, correct? It's ever increasing number of transactions. So that would be another another blockage or another bottleneck. So to overcome this, machine learning can benefit blockchain and blockchain can benefit machine learning. For an example, how blockchain can benefit machine learning, correct? The first one, in machine learning, there was a limitation. So let's see the machine learning's limitations. Okay, so there was a limitation of machine learning. When we have a decentralized architecture, the data sharing becomes unsecured and efficiency is not there. Whereas using the blockchain, security and privacy becomes very high in the decentralized architecture because there is a trusted decision-making process and consensus protocol. Using this, blockchain can improve the security and decentralization of machine learning. Efficient data sharing will also happen. Now, machine learning can operate blockchain intelligently in such so that the energy and resource efficiency is higher, so that the energy consumption is low. And the scalability is also in control for ever increasing transactions. So machine learning can take some intelligent guesses and then control the scalability. Now, again, in blockchain also there is a risk of 51% attack. So let's say 51% of the miners are malicious, then they decide to go and hack it. Now, machine learning can immediately identify this kind of attacks intelligently and improve the security and privacy for blockchain also. Now, since there are smart contracts, we said they are automatically executed. Machine learning can play an important role to make smart contracts even more smarter. Correct? All these smart contracts, they can be driven through the machine learning. Now, three different architectures. So first is, you can see the centralized approach, where you can see different learnings they have to report to the central controller, and everything, all AI algorithms, they operate at a center. Now, what if this goes off, right? That's the biggest trouble. What if this goes off? The central ML architecture, right? That goes off, then there is a trouble, entire system is down. Second is a kind of a semi-central architecture where learning is done at the edges, but they are fused at the center. Again, it's somewhere in between. What if the central controller goes down? So that's why this blockchain-based distributed architecture is in the proposal, so that without the requirement of a central architecture, I can do the communication over a network with machine learning, correct? So they can operate together and take the advantages of each other. So you can see the difference is clear from centralized approach to the decentralized approach through machine learning and blockchain together. What are the benefits? So you can see the feature of blockchains where it was a shared ledger which is transparent to each other, everyone, which is an immutable and irreversible. Once the block is added in the chain, it cannot be changed or it cannot be reversed. So that's the best part, and everyone is having a copy. So security is very high, security is very high, and privacy is high because it's completely hashed through SHA 256. So the privacy, those are highly encrypted, cannot be easily decoded because cryptographic algorithms are in place to take care of the privacy, right? So the sharing becomes highly secured and efficient also. So these are the major benefits of my blockchain to the machine learning, correct? And that we have already discussed that some of the blockchain can benefit in machine learning, that training and data sharing can become very efficient considering the privacy concern that we have also discussed. And then it's pseudomonas, so that the identities are not going to be disclosed. So using the blockchain cryptographic algorithm, so this is highly secured, and identities are preserved, private. So they come. No one comes to know that who is transacting because the privacy is preserved. Whereas the machine learning can benefit blockchain by improving the energy efficiency, resource efficiency, and scalability. As we have discussed, that those consensus protocols, adding the blocks is highly consuming the energy. So machine learning can decide where the energy efficiency can be increased, and the blockchain's performance can be optimized to save the energy, and scalability can also be in control. So these are the major advantages of machine learning to the blockchain. So finally, if I summarize, correct? So in 5G or 6G core, alone application of blockchain or alone application of machine learning may not be that much of efficient compared with when we go with an integrated approach or hybrid approach. So that's why the machine learning's benefit to the blockchain and blockchain's benefits to machine learning, they are brought into the picture, and both of them together, they can work with each other and take the advantages. Now, there are a few open resources and open issues and challenges that are faced by the research community. So first one is the integration. How will you integrate the blockchain and machine learning in the communication system? And how will you build those hardwares which are compatible with the softwares, right? So that's a major question right now. So the answer to that is this Python interface is very good. So mostly the MATLAB can be used for machine learning the wireless communication setup. The setup can be exported and given to the Jupyter notebook, which is with a Python, or you can have your own Python code also. That is also feasible. And from there, own Python code, you can write the blockchain and machine learning codes together to drive the system of communication. Second one is the interoperability with multiple blockchains in the communication segments, right? So that's another bottleneck. Then when we want to interoperate the different blockchains in communication segments, then there is a trouble. Third one is we have to integrate the consensus protocols with deep learning or machine learning. So consensus protocols should be dynamic, and it should be integrated with deep learning and machine learning so that it can be very efficient. So that's another open challenge of our research right now. The decentralized, now there is always a debate between decentralization and centralization. Some of the people will say centralization is good. Some of the people will say decentralization is good. Some of the people will say semi-centralization is good. So there is no exact answer to that, correct? So the question is decentralization, how will we achieve that decentralization? How to improve the security and privacy issues, that would be addressed by the blockchain very nicely. And data model sharing, this is efficient data model sharing. This is also an open challenge. Resource management, energy efficiency, scalability, all these are the open challenges on blockchain. So that's all I have for this session, and maybe last minute we can spend on Q&A, question and answers, if you have any. Am I audible, madam?
Yes, sir. Yes, sir.
Okay. If there are any questions, please feel free
Sir, good afternoon, sir. This is Selvi from Jayam College, Tamil Nadu.
Good afternoon, madam.
Sir, can you explain difference between deep learning and machine learning, sir?
Yeah, okay. So in generally deep learning, we used to have a multiple of those number of hidden layers, and then what happens that it based on the biases and weights, they adjust it nicely and automatically they predict everything without any intervention. There, whereas in the machine learning, this application of the hidden layers and other things will not be. That's a basic one. So application of this hidden layers and other things. Let me check if I have any slide on that. I remember I had one slide. So let me open that and show you so that you can have a detailed one.
Okay.
I'm just opening the slide. Yeah. I think in the morning we have covered it.
Yes, sir. That's why I'm
Yeah,
asking.
here it is. Here it is. Oh, let me share it. Let me know when you see my screen. So you can see the application of those. So in machine learning, what happens that it's kind of an outer ring of a deep learning. So deep learning is further goes into the machine learning, right? You need this kind of networks. Where is it? Yeah, but you can see this part. Are you able to see my screen, madam? I've zoomed it so that you
Yes,
can
sir.
see.
Yes, sir.
So this hidden layers, right? There would be multiple hidden layers in the deep learning part, correct? And using those number of hidden layers and no adjusting this firing of the neurons and adjusting those weights and biases, we can predict and identify the decisions. Whereas in machine learning, this part won't be there. It's just based on this labeled data. It immediately identifies, okay, that this is a cat or dog or this kind of thing. So any other question, madam?
Yes, sir.
By third lecture, my energy is pretty much down.
Hello.
Yeah, please, madam, go ahead.
Sir, there are various properties you have discussed about blockchain. So in that one is immutability. So that I want to know what is the meaning in the sense that in case of the blockchains, what do you mean by the immutability in this case?
So what happens when we add a block in a chain?
Yeah.
It cannot be changed.
Okay. So that
And
one more word that was you used, irreversible. So that is the same thing,
no,
immutability.
now the second thing, it cannot be changed. Now
Okay.
let's say some node is malicious. Any node is malicious,
Okay.
and it want to do the tempering. So it will try to temper the blockchain, right? Any blocks or anything.
Oh.
Now what happens that we have a copy shared across all the blocks, all the nodes.
Yeah.
Immediately it will identify that this is not mutable. So it will say there is something wrong is happening. Someone is trying to change anything, correct? So, and
Okay.
our copy says that is not mutable. Correct? So
Yeah.
that copy is with across all of us, right? So we see that there is a difference coming out from somewhere. So this is the segment where the changes are coming. So we will say, okay, no, that's something wrong. This is the original copy and you're trying to change it. So that would be highlighted immediately and expelled from the participants, right? So it will be marked and then it will be expelled from the existing system. And then the original chain would be restored, right? So everyone has a copy. So that's how it is highly immutable. So no one can try to, so this mutation is very difficult.
Okay, sir. One more thing is that in the process of blockchain formation, nonce was there. So that I I'm not able to understand what is this nonce.
Nonce means it's a number used once. It would be used only once in any of the block when you generate SHA 256, correct? So it's
Yeah,
it's
yeah.
kind of a
One example you have shown. So in that we have to insert every time, or it is
automatically
already
it would be, yeah, automatically it would be a
automatically
random
it will
number.
take.
It
Okay.
will be taken automatically, random number that would be used. Let me share my screen.
Yeah, that
So,
I've seen, sir, the example, but
uh,
I could not
okay.
understand that. What is the
So
meaning?
nonce is number used once. So what is that? That means that kind of a random seed. One seed
Okay.
is used to do the hashing.
Okay, fine. And hashing means, sir, one more thing that some, because do not have too much of idea, and
Hmm.
the basic things which
Hmm.
I am learning from this
Hmm.
lecture. So one more thing is that in this case, hashing means this is a encryption method, na? So but
Yes, yes, yes.
hashing means the encryption method.
Correct, correct.
Yeah.
Similar to encryption. SHA
Okay.
256 we are employing. SHA 256 algorithm we are employing. That secured hashing algorithm is for encryption only.
Okay. Okay. Thank you,
You can
sir.
use any other algorithm
Yeah.
also, but this particular portal is coded with SHA 256.
Okay, sir.
I might be going short in the last lecture because the last lecture is so difficult to speak again. It's from
Yeah,
morning.
yeah, no, but it was quite good, sir. That because some of the terms we were not aware of all these things. Basics we know about, but you have taken in detail, and most of the things are clear to me.
No,
Thank
some
you,
of the
sir.
things I am not able to deliver as per the highest expectation of mine because I've been generally if I'm in the morning I'll be with a full energy and then
Yeah.
at the end evening we go down slightly.
Okay, sir. Thank you, sir. Thanks a lot.
Any other
Other
questions
questions,
from anybody?
madam or sir?
Any questions from any participants? Please ask now. I think there are no questions, Rahul sir. Thank you, sir.
Thank you very much, sir. Thank you very much for
So the
inviting.
final proceedings handed over to Saujanya madam, please.
Yes, sir.
Naresh sir, please slide, please.
It's my privilege to propose a vote of thanks for the day. On behalf of our Vardhaman Engineering College family and the audience, I would like to thank our distinguished speaker, Dr. Rahul Jashvantbhai Pandya sir, for taking out the time from his busy schedule to provide us with such a valuable information on artificial intelligence and wireless communication systems, blockchain technology applications, limitations, how machine learning can benefit from blockchain technology, and integrated blockchain and machine learning systems, and the open research challenges and perspectives. Especially demo of that blockchain technology is fascinating. So now I request program coordinator sir to facilitate our distinguished speaker of the day, Dr. Rahul Jashvantbhai Pandya sir.
It is our honor, sir. So here we are running in the online mode. So the shields and everything are virtual. So we are giving a token of appreciation from our end, sir. So thank you for your lecture from the morning session and the afternoon session. And I'd like to extend my thanks to you. Within a single word, you accepted our invitation. So thank you for that also, sir.
Thank you very much, sir, for inviting.
Yes, right.
Thank you very much. It's an
And the
opportunity
final
because
proceedings. Yes, please,
because
sir.
with
Please.
this I learn also. When I teach, when I learn. So when I teach, I learn. So that's an opportunity for me to learn also.
Yes, sir.
Otherwise, we'll be teaching digital systems only, or maybe some code system.
Yes, sir. Thank you, sir. And the final proceedings handed over to Harini, madam. Please announce about the links and.
Yeah, good afternoon, participants. I'll be sharing the links in the chat box as well as your WhatsApp. We'll be even receiving your emails also. Please attend for your assessment for day 3 as well as the feedback session.
Thank you all. Signing off day 3.
Thank you very much, sir.
Thank you, sir. Thank you.
Attend for your assessment for day 3 as well as the feedback session.
Thank you all. Signing off day 3.
Thank you very much, sir.
Thank you, sir. Thank you.
Attend for your